Okay, just waiting to make sure this is showing up. Um, okay. So, I guess, let me just show you what I've worked on. So I want to work on, so I've been working on this SDF path tracer, Spectra. It's a global illumination path tracer for SDFs, and I want to improve it a bit today. So first thing, I guess the first thing I should do is, since it's been a while, last time I worked on it, I guess I'll step through the code first. Alright, create window, nothing special. Engine track all code files. This is where I'm hooking into all the shader files, and so that each frame I can check if those files being edited, and I can load them on the spot if they get changed. Track event. Okay, so here is the shader reloading. If we go into the update and render, which is the meat of the engine, initialize, enable debug layer, create device, GPU context, descriptor, UI system. UI system is something I worked on since the last stream. Pretty much just it loads a font, and this job is just to render text, nothing too special. Alright, nothing too exciting here. Now it's just a bunch of PSO initializations, loading balloon noise texture, initializing the textures. Okay. Yeah, I guess I didn't need to step through this code, huh? So one thing I didn't talk about is how the render is architectured. Actually, it's pretty straightforward. So primary rays, you shoot rays from the camera to the scene. This is equivalent to, say, a G-buffer laydown in a typical differentiating pipeline. So it just records the position at each pixel, the normal and albedo, emission, and ray direction. Then correlate history pixels is sort of equivalent to a screen space velocity pass. This is just so that when you do temporal filter for either the denoiser or the TAA pass, you know which where the location in the history buffer your pixel correspond to. Since both denoiser and TAA needs this information, I pull this out into a separate pass. Compute this occlusion. This is sort of a special thing. What it does is that it basically looks at the correlation of the history pixels and say, well, did the history exist? So first thing it checks is, was the history outside of the screen? If it is, then mark the pixel as newly secluded regions. And if the history's geometric features don't match the current pixel's geometric features, we can also consider the reprojection as a failure and say this is also newly secluded as well. Now this is needed because since we're doing a path tracer, those secluded regions, they need to be treated in a if we just shoot one GI ray, that means it only gets one sample, and that's not going to look good on those secluded regions. So what we want to do is to mark those pixels as secluded, and when we do actual path tracing for the secluded regions, we shoot a bunch of more rays, and for the pixels that already pre-exist, we just shoot one ray, and the denoiser is going to be able to pick that up and temporally filter and then spatial filter it. The package buffer basically just packs the G-buffer, which is quite thick up to this point, into a texture with about 4 D words per pixel, so that since the temporal filter, both the temporal filter and the spatial filter, are quite heavy on the memory traffic, we want to shrink the G-buffer size before we really get to the heavy work, right? Now the temporal filter, it's quite straightforward. You just look at the history, and you here we do exponential moving average, variance. Okay, variance. This is the so if I haven't mentioned it, the denoiser I'm working with is a spatial temporal variance guided denoiser. The variance basically tells the spatial filter, okay, if the variance is higher at this region, that means it's noisier, and therefore the spatial filter needs to be stronger. So here is, you can see I do 6 iterations of this is a 2 wavelet filter with a 3x3 memory footprint. Then after the denoising on the GI buffer, I just apply primary shading, composite all the colors together. Then, well, I forgot about this. I have an option for comparing just temporal filter and spatial temporal filter. I guess I'll show that in a little bit. TAA, this is nothing new. Then tone map, and pretty much that's the end of it. Then we copy the result to the back buffer and draw message. I guess draw message is kind of special, but nothing really interesting going on. It's just pushing the text onto the screen so you can see them. So then it results in something like this. So I have a slider that shows a noisy image. This is purely temporal filtered with no spatial filter, and you can see spatial filter sort of cleans that up a little bit. Now the other feature I worked on was, so say before I added the scene, I have some say the scene wasn't compiling before, say fuck, it would have been a message box popping out telling me that it's going wrong, but this time it's text, which is more graceful and less intrusive. Alright, so that pretty much covers what has been happening in the past since the last stream. So what I want to do today is first finish up the tonal modeling. So the one thing I really want to do is add more details to the tunnel. If this compiles, I don't know why it's taking so long. Interesting. 19 seconds. Okay, that's not long at all. So if I go to the tunnel, you can see, okay, we got some textures on the road. We got a ball in the middle for some reason, but the walls are really smooth. I want to change that. So I guess the first thing I'll do is try to live edit the walls. So I want to do like a classic bump map. So have the walls be made out of like blocks, if you know what I mean. Let's go to the tunnel. So I guess what I want, let's think this through first. So what I want to do is kind of, okay, so this is from 0 to 1. I want to have a bump map function that tells me, so here at 0, it's pretty much not changed, but as it goes up, I wanted to say, okay, the height of the surface is increasing. Then after it continues for a little bit, I want to fall back off, and if I can repeat this pattern I get something like a blocky bump map on the wall, right? So now I just have to figure out how I want to do that. So I guess this could be achieved with two opposing step functions, I'm thinking. But then it'll be a sharp cutoff. I want to be like a smooth cutoff so that so the differentials are defined. Let's see. So I guess instead of two opposing step functions, I'll use two opposing smooth step functions. Let's see. So the first thing I guess is, before we even get to that, we sort of need our own texture coordinate for the wall. So this is a 3D position. It's kind of hard to do bump mapping on a 3D coordinate. I want to kind of transform this into a 2D coordinate, like a UV coordinate. So let's try that. First thing is, so when the coordinate, so if the point is going around the circle, so say the z-axis, which is forward, doesn't change, it goes around. I want this to be from 0 to 1, or just the number to be increasing along this dimension, if you know what I'm talking about. And so that'll probably be u in the texture coordinate, and I also want v to be the number going through z-axis, so that's just z-axis. That should be quite simple. So u is z-axis, and v is let's see. So that'll be the I guess we can do this by having like a horizon angle as v, and that would be the tangent of height over width. I'm guessing. So first, does this compile? Yes, it does. Let's just map the UV onto the screen. Let's see what we're working with here. Let's do frac. Okay, it looks reasonable, if I can say so. You can see the the textures coordinate space is actually wrapped onto the tonal surface, which is what we want. But the frequency of the texture space is kind of one-sided. It's at a really high frequency along z-axis, but not so much around the horizon. So let's just arbitrarily scale it by a little bit. This is more like it. Maybe a little too high. Well, let's just start with this for now. Okay, so this is our texture map now. I forgot I was in my map material, so really I want to be up here, I think. So UV. When we do tunnel, we want to use this UV to modulate the distance to the tunnel, so that we have a height map effect. Let's see. So tunnel plus minus some. I don't want this modulation be really too much, because then the sign distance field would degrade into a fake sign distance field. And we're going to start seeing artifacts. So I'm just going to multiply whatever the differential I apply here by a small value, so it looks alright. Smooth step. Let me just look up smooth step. Min max x. 0. Okay, I see. Alright, so we can have, I guess we can have we can have the height map function be a multiply of two smooth step functions. Again, if I go back to the notes, do I still have that, or did I delete that? I think I did delete that. Anyways, so basically what I want to do, let me just go back to that. Oh, I still have that. So this shape can be constructed by two smooth step functions, one looking like this. If I could get the... Oh man, ASCII art is hard. So this is one signal, so this is the signal can be made out of the multiply of these two. So I bet you can see where I'm going with this already, but let me just make this clear. So these two signals multiplied in the middle, they're not going to change. It's still going to be 1, but on each side they're going to get reduced gradually when they go towards two extremes. Alright, but how can we do that? Smooth step. Damn it. Okay, trying to think here. Thinking live is not very easy. I guess the first will be you, and this will be something like this. Does that work? Oh, it did do something. I guess. Okay, let's try to look at it without the spatial filter, which is getting rid of some of the ambient occlusion. Okay, so I guess it's getting bump mapped correctly here. Well, let's just get rid of the UV texture albedo that's interfering with this. Yeah, so we're seeing the stripes we want, the height map. This is exactly what we want. Now we're doing it along the U dimension. We just need to do that along the V direction as well. So this is becoming a very long expression. So UV, this is V, this is V. Something went wrong. Okay, I guess. So we got the bump map function in 1D. Now I'm just trying to extend that to 2D. Let's see. This should work. I'm not getting why it's not working. So what if I do this just along V? Does that work? This also works. Some pretty strange artifacts showing up. Well, I guess that has to do with a lot of sampling error. Okay, I want to be a little more forgiving in the corners, and this is not good. The denoiser is destroying all that ambient occlusion. Okay, so now if I multiply, this is, let's just say, U mod. Should be the same V mod. For some reason I get this. Not even sure what this is. What, do you have to add them or something? Oh, maybe I did, but okay, but there is some strange artifacts, so I guess we need to go lower than that. Well, one thing we can do is we can just say, okay, we're working with the SDF that's been degraded a lot. Let's just cut the distance to it by half. It's going to be a whole lot slower to trace, but at least it gives us more correct results. I think it looks a lot better, but it's a lot laggier, of course. We can do better. So if it's laggy like this, one thing we could do is having like a guard function on the SDF. So say if I'm querying a point that's nowhere near the surface, then I shouldn't even need to apply this bump map function to it. So if Tonal, if the distance is like say 0.2, then I really don't need to do any of this stuff, right? Not even this. So only if the point gets close enough to the surface, we need to start modulating it with the height map. So this gives us the exact same thing, but not even that much faster, I guess. Well, that's a bummer. I guess this is what we have to work with. I think I'm gonna leave it like this. Well, I don't claim myself as some kind of procedural modeling. I'm not quite experiencing that, so this is good enough for me. Alright. So the tunnel is pretty much complete. The next thing I want to do, I guess, is add directional light source support. So now, let me just switch to a scene that's so that when the sunlight gets added, it's a little easier to see. Let me try a demo. I forgot what that is already. Okay, it's just two spheres. This is perfect for the directional light case. Okay, so the thing is, right now in the application, the only way to have light source is either to define a emission on the surface of the geometry, or use environment light, which is not a ton too interesting. Well, you could implement directional light with environment light source, right? So you could just say, so in here in the demo environment, you can see I have a ray direction passed in. So we could say, okay, let me specify a L vector that's just a direction towards the sun, some value with a positive y at least. So I can say, okay, something like this. And we have sky, which is constant. Sky plus sun. And sun is, so sun by default is not going to be present. But if the ray direction is sort of shooting, like if the ray direction is shooting toward the sun direction within this much of a cosine space, then we say, actually it's probably much less than that. Then we say, okay, the sun is affecting the surface if we're sampling the environment at this direction. Interesting. I guess I forgot to clamp. Or I can just say max 0. This is it? It's doing something. It's not doing what I want. That is strange. Oh, hold on a second. I seem to be forgetting where the environment light gets called. So .L. This isn't quite right. It's like the bottom half of the hemisphere is sun. Okay, I went into the floor too deep. Could I visualize just the sun? For some reason this gives me a much bigger surface than I expected. Let's see here. .L. Oh, not remembering my math. Okay, so there's directional light, and let me just add back the sky. So, whoa, the sky is way too strong. So this is closer to directional light. So actually it's quite straightforward to implement, but you can see, go up. That sun is too big. So a real sun will be much smaller. Maybe 0.99, or not even that. Should be even smaller than that. And it's gonna be really strong, right? Now the issue with that is the sun is gonna be incredibly hard to sample, because what we're doing is Monte Carlo integration. We're just gambling. Say if the ray hits the sun, then we sample from it, but chances are we're never gonna hit the sun, or at least not a whole bunch of time. So you can see something is spazzing out. That's just because the incredible amount of noise my spatial filter is taking in. If I remove spatial filter, so just show the temporal filter, there's an incredible amount of noise in the signal. This is why right now you could do directional light, but I don't really advise it because it's just looking real bad if the sun is at a plausible size and plausible strength. So by directional light supports, I really mean like a next event estimation support for the directional light. So next event estimations is kind of a simple idea with a funny name. Basically, we just say, okay, so far we've been relying on gambling to get the sunlight. How about we just explicitly shoot a ray towards the sun to see if the sun is actually affecting any vertices in your light path, and if it is, count that as a contribution. Now, to avoid to double count the sunlight contribution, when the ray actually hits the sun, you don't do anything. So there's the idea of that. So let me just get rid of that. So all I want is a skylight. Now from the user side, we need the user to define a new function. So basically, sun direction and sunlight. In our demo, we can just say we can just set the sun direction to what we had before. Sunlight it's got to be really real strong. And I'm wondering if I should add like sun aperture, but I guess now we can just first implement like a perfectly directional sunlight as a first pass. Okay, so the thing we need to change is our path tracer. Let me just go over the code a little bit. So by this point we already have the primary geometry, which is P and hit normal, just the position and normal of the primary surface. Path trace, it really collects the indirect illumination instead of the direct illumination, so I kind of want to separate that. Huh. So I guess what I'm trying to get at is, no, you know what, never mind. I was just thinking, should I do explicit light sampling on the primary surface, because that will correspond to doing direct lighting. And direct lighting, if you look at the frequency of direct light signal and indirect light signal, they're wildly different. We can get a lot of benefit from separating those signals, and if we denoise them separately, the quality should be a lot higher. So I was thinking I want to do it in that direction. So defer the direct light sampling till when I actually shade the primary surface. But I guess that it's not going to quite work, because then the shading is going to be noisy. So I guess I have to do, yeah, I'm just going to do like a regular path tracing with the next event estimation on every junction in my light path then. So that's what I'm going to do. Alright. So let's see here. Sample bounce count. So this is basically the main loop of my path tracer. This is where the light bounces around. We can see where we reset the hit position, then restart at the beginning of each iteration. And right currently it's about 3 bounces. So let's think where we should add this. Okay, so now we initially start from a hit position and hit normal of the primary surface. First thing I want to do, of course, is that each time we arrive at the vertex, we want to shoot our ray toward the sun to sample how much contribution the sun has to that vertex. And the first primary surface point is our first vertex. So we really want to do our sun explicitly sampling here then. So if dot sun direction, which is the user supplied function here, sun direction is, no, I'm not comparing with direction, I'm actually tracing a ray here. So where's my ray marching function? Okay, here it is. So I guess first I can say if the hit normal, so if the surface is facing away from the sun, there will be no point casting that explicit light sampling at all, because that surface just wouldn't see the sun. But so hit normal and sun direction. So if they happen to be on the same half plane, then we want to kind of sample the sunlight. So what I want to do is from hit P. Do you want to reuse this? Well, whatever. I'm just going to do the same thing here. So again, we want to push it off the surface. What the hell? We want to push it off the surface a little bit. And the ray direction is going to be the sun direction, because that's where we're sampling. If sun hit, now I use material index to denote if I hit anything. If the material index is equal to -1, that means there's no occluder in between the surface and the sun. Then what I do is have this attenuation. Guess we can do the same thing here. So here, sample plus equals not the attenuation but the sunlight, or the sun contribution, since We also need to take into account the cosine attenuation with the sunlight here. We don't need we still need the BRDF. We still need it for the primary surface shading. You know what? Let's just ignore that for now. But sun contribution, that should just be the dot product of the hit normal and the sun direction. And we don't need to clamp because we already have this precondition that they're in the same half space, so it's got to be at some positive value. And we multiply this by sunlight, and there's our sun contribution. Now this should work. I guess it doesn't quite work just yet. Let's see what we're missing. So, some Hansen. Could it be that? No, never mind. Okay, sun contribution. What if I just do this? Sample plus equals attenuation. Let's just do this. At least let's make sure all the environment settings are correct here. Okay, I think this is right. Yeah, this looks right. So we got the sun direction in. Maybe the sunlight was just a bit too strong, is what I'm thinking. So let's try to tune down the sunlight by a little bit. Oh yes. Now we have perfectly directional light, which doesn't look that great. But it's a lot less noisier than what we had before. Go back to 1. Okay, this is something a lot more reasonable. For some reason the shadow is still fuzzy because our denoiser is not... There should be perfectly separable signals because there's literally 0 noise on the boundary. Yeah, it looks good. Now I guess we just have to support a sun with a finite solid angle instead of a 0 solid angle. I'll make it a 2. No, I guess 1. Sun aperture. Is that how you spell aperture? I'm not sure. Doesn't matter. Okay. I'm actually not even sure what the unit of the sun aperture is gonna be. I just just put this in there. You know, why not? I guess I'm just gonna make it whatever unit I want it to be. So sun direction, and now this time we're gonna seriously try to generate a direction in that. We're gonna try to generate a direction within a certain solid angle towards the direction. And I'm not remembering the equation for that, so I'm looking it up. always a good guide. Global Illumination Compendium. It has all the sampling that I need. Where's the information? I want to see like a web version. Does it not have a web version? Okay, let's see what we're looking for. So hemisphere geometry. We want sampling. Where is it? I guess this is what we want to be in. Page 15. Does that look about right? I don't know. I'm trying to decode what it's trying to say. I think it's just the coordinate transformation layer. The solid angle, this doesn't really tell me much. Okay, it's computing the solid angle. I want like a function that can sample it. Okay, page 43. Solid angle G. I wonder how much easier it will be to do this. Yeah, I don't know if I want to like have a real solid angle sampler. I might just come up with my own hack for that. So I guess what I'm gonna do is, okay, so this is what I'm gonna do. Let me go back to the note. Hopefully I can sort of jot down my ideas in ASCII. So basically, we already have a hemisphere sampling function that's cosine weighted, right? So this gives us something that, given a normal and some seed, it gives us a random direction. And if we really step into that function, we can see the random direction is generated by projecting. So it picks it uniformly sample the disk that is tangent to the normal, and what it does is that pick a random spot in the disk and project it up in the hemisphere. Now, this is sampling the entire hemisphere. I can tweak this to only sample a specific subset of the disk, and when they get projected to the hemisphere, it will be like a hemisphere that's constrained in a certain solid angle. You know what I'm saying? So I can first construct a coordinate space with the normal pointing at the sun direction, and then have a tweaked version of this function where the radius is restricted. Could be a very small radius, but you can imagine a small disk projected up into hemisphere. That's like a small solid angle. So, well, I guess the notes didn't really do anything. The ASCII art is not being too useful here. Sample hemisphere. I guess I can have an extra variable here called radius scale. No. I'm just gonna have a totally separate function for that then. So sample cone cosine weighted. So this is the aperture, which is just a fancy name for my own unit. I'm not even sure what unit it is in, but I'm just going to apply that by the radius. Now this should give us what we need. Again, I don't know what direction this is in, but this should be close enough. This is very I think it's very intuitive because an aperture of 1 corresponds to the sun being covering everything in the environment, and a light being about 0.1, then okay, that covers about 0.1 in a disk, and therefore 0.1 in a hemisphere. I think there's a very clear correspondence between this aperture unit to what is actually going on, so I'm going to stick to it. Sun sample direction, I guess. This is what was it called? Sample cone. Okay. The normal, which in this case will be the sun direction. R, I'm just going to do like have a little random generator in the GPU here. Then I can do aperture, which will be supplied by the user, right? The sun sample direction. Now we just replace everything with the sun sample direction. Alright. What does this give us? You know, not bad. So let's try and increase the aperture a little bit, just making sure that the aperture is actually working. Yep, I think it's certainly working. A little bigger. 0.5. Now it's mostly turned to soft shadow, right? I think it'll be best if we have one of the sphere be kind of farther away, so that the shadow caster is farther from surface. We can see a very pronounced penumbra. to just verify that this works. Where do I want to have the sphere? Okay. Now the sun direction just have to be a little less vertical. This is a bad spot. Alright. Now you can see, hopefully, the shadow from the sphere, which is farther from the caster. The shadow caster is a lot fuzzier on the boundaries than the shadow caster that's closer. So that's correct behavior. Now, as the aperture gets bigger, it gets this phenomenon gets much worse. There you go. Let's see how noisy this is without this. It's actually not that bad. It's a pretty clean signal. Okay, so I guess we cracked directional light support then. I guess one thing I want to test, just trying to experiment with this, is so I'm not really a huge fan of how we're lighting the tunnel right now. So if I go back to the tunnel scene, you can see that we're lighting with oh god, this artifact. Okay, anyways, we're lighting with this stripe light, and it's kind of producing like a monotone lighting. So I might as well just have lighting going off everywhere on the surface than actually sample that, right? So instead, what I want to do is so remove this light and carve like a hole on the Tonal's wall and have the sunlight shining in, and I think that'll probably produce a much more interesting results. So why don't we do that? All right. So let's say we don't need this anymore, and do we have a SD box? I guess we don't need one. So one thing we can do to the tunnel is say so I want like a negative space. So the way I guess I'm not really explaining, but so what is going on is I'm creating a sphere, sine distance field, and this is gonna be, so inside itself is gonna be, in the solid region it's gonna be negative values, and the outside empty region is gonna be positive values. If I negate this, then I basically turn this shape into a hollow shape with the, so instead the outside of the sphere is filled and the inside of the sphere is empty. What I can do with this is to do an intersection operation of this shape with the tunnel to carve a hole in the tunnel's wall. So I can do that pretty easily. But first, let me just try to see where the negate shape is. What? Sphere identifier represent. I'm not calling a function. Oh yeah, I am. Okay. So here's a sphere. Let me just try and move that around. Make sure it's intersecting on the wall there. So probably -2, -1, 0, 0. Let's start with the careful value. Okay, we need a lot more. 4. That's interesting lighting. Hopefully we get some more of that after we open up the tunnel. So 5, going up a little bit. Alright, that's a nice spot. We increase the radius. Okay, I think that's good. I think that's solid. So now what we do is tunnel. We do intersection operation with the negative shape. So now there should be a hole in the tunnel. Or not, because the tunnel is actually solid. So the tunnel is solid outside. I forgot about that. Okay. But there's something we can do about that. It's just thinning out the surface. So instead, oh boy. So instead, so I don't know if the modulation, I'm not sure how the modulation is gonna affect this technique, but what we can do is tunnel absolute value and the sort of the radius, the thickness of the geometry. Okay, now it's showing, but it's kind of destroying the bump map, which is not good. Whoa, that is cool. That is really cool. Holy shit. I like that a lot. I might just want to start modeling on the outside, because this looks a lot nicer than the inside. Okay, anyways, 0.1. Okay, if it's thinner, we're still preserve some of that detail, so that's good. Ooh, this is cool. What have I just discovered? Wow. Well, we can play around with that idea later. Sorry. 0.1. Alright, we still have some of that bump map, which is good. Now what we want is to turn off that emissive surface completely, because it just looks bad. And what we want to do, this looks nice. I think it's mostly just, we don't even have any environment light, do we? It's just sunlight. So right now sunlight is facing kind of the opposite direction here. Just, whoa, this looks like subsurface scattering. It's so cool. Anyways, now the sun is casting the wrong direction, right? Holy shit, look at that. Dude, that looks so fucking good. Anyways, seems like the scene is just lit based on the sun, secondary sun bounce back into the tunnel. So why don't we change the direction of the sunlight to be shining inside the tunnel? Whoa. Now that is cool. Not quite enough to light kind of all of the tunnel though. But I'm liking this already. 10. This is looking real nice. Yeah, this is, I don't even really need like a fog function. I mean, this just attenuates in the distance automatically. This is so nice. So I guess I'm keeping this. This is, whoa. Okay, that's much better color, I think. Maybe something like 3 or 4, maybe 5. And the black sky doesn't look quite right. It's like on a moon or something. So let me add some of that skylight in as well. Doesn't really show up, huh? That is because my fog is bad. Oops, I meant 1. So now I don't know, do we want the skylight at all? It's not really contributing to any lighting inside, is it? So yeah, I think I'm gonna say no skylight. I mean no skylight. And bring the fog back because it's just a nicer, it creates a nicer atmosphere, I think. But man, like I was trying to model inside this whole time, but look at the outside. It looks much nicer. Doesn't it? On the back. I think the GI really shows here. I mean, it just looks so realistic to me. For some reason the surface looks like it's some kind of human skin, but I like the feeling that this scene kind of evokes. If you know what I'm talking about. Wow. Alright, so we got that. So I guess one thing we can do is, so another thing we can try is to periodically carve a hole along the z-axis. So every each time we step forward by 1, we carve a new hole in there. Holy shit! Look at that! Look at how beautiful it looks. This is amazing. But maybe a sphere? Maybe this cutout is too unnatural, you know? Maybe I want to add a little bit of modulation on the boundaries of this cutout. Let's try that. So, where was I? Okay. So I could just add, I guess I could just modulate by FBM, but that's gonna be expensive. Maybe a bunch of sine waves just to see what it looks like. Doesn't really change anything because the frequency is too low. Let's try bump that up a little bit. Holy shit! Doesn't that look cool? I mean, that's not intended. I was actually trying to make some. Holy fuck! I was just trying to cut out like a shape, but this looks way cooler than what I hoped for. Oh man. Look at that. Okay. So let me plot this frequency, just so it becomes easier to tweak. Okay, that's actually not bad, huh? Actually looks half decent, I'd say. Yeah, this might be a better shape than just a perfect clean circle then. Yeah, this is better. You know, I think I'm happy with where the scene is going. And look at the outside. Oh my god, I just need to see this one more time. Yeah, this is so good. Trying to bring the non-spatial filter version. This also looks real nice, but it's just not as smooth. Yeah, when it's smoothed out, there's something about it that makes it look nice to me. What the hell? Okay. So I think we might be done with modeling the tunnel. It looks real. I'm real pleased with it. Yeah, so I guess we finished up the tunnel, and we also have directional light support now. Hold on a second. What if I add a different color to the sunlight? Right now it's just a monotone 3 on each channel, but it doesn't have to be that way. Ooh, that's a yellow. I don't know. I think the monotone is the best. Alrighty. So let's see what else we have on a to-do list. So we got directional light support. We need. Guess they're not really perf counters. So I guess what I want to do next is to collect statistics on each how much time each pass takes, and that is particularly annoying because okay, I guess not that annoying. So let me just try to explain my thought process here. I still have this. Okay, so now if you remember, last time I did CPU and GPU pipelining, right? So the way I got that pipeline efficiency is by having the CPU and GPU running at the same time. Well, I had multiple frames in flight, so basically, so one way we can do rendering is CPU plus GPU, single buffering. Well, by plus I mean CPU stalled by GPU, I guess. This is what I'm trying to say. So basically, if you look at the block, so first CPU builds the command buffer, sends it off, GPU processes it, CPU waits, GPU is done, go back to CPU. GPU is waiting for the command to get built, and then GPU executes again. You can see this is quite an inefficient pattern because at any time there's one unit just idling, and the execution time of this is the execution time of CPU plus execution time of GPU. Instead, what we can do is CPU GPU pipeline or double buffering or triple buffering if you like that. So CPU, what happens is, okay, this is the first frame, GPU doesn't do anything until CPU sends a command buffer. Okay, sends a command buffer, but the thing on the CPU is that it keeps track of multiple frames. So now, while GPU is processing the last frame, I can say now I want to process the command buffer for the next frame, and GPU. Well, this is the perfect case where the pipeline is perfect, but there's no bubble, but that's rarely perfect. But you can see by having the GPU processing one frame late always, we're essentially utilizing both units at the same time. If the execution time is the same. So instead, the execution time of a pipeline or the double buffer strategy render is going to be the maximum of execution time of CPU and the maximum execution time of GPU, right? Now, there is going to be a problem arising with this strategy. So let me just talk about resources. This is pipelining. There's sort of two types of resources on the GPU. So when you deal with like explicit rendering API like d3d12 or Vulkan, the thing is there's gonna be like a permanent resource and there's gonna be transient resource. So I guess persistent resource is things that don't really change per frame. Like it doesn't have to get dynamically updated from the app side. So this will be equivalent to, say, the gbuffer texture. Gbuffer texture gets updated by your shaders every time. So even if we pipeline this, you can see GPU themselves don't overlap. So it's fine to have persistent resource, no problem really, because I can have a single. So I have a single gbuffer texture. There's only going to be a single GPU workload touching that one texture at the same time, so that's okay. So the second type of resource is per frame resource. Now that is problematic because per frame resource are like things, say you update, they're like a constant buffer that you pump with your app data per frame. That is problematic because imagine we have some per frame resource for CPU 0. So okay, we got the constant buffer for frame 0. We updated that to the GPU. Now GPU is ready to execute on the buffer 0. Wait, hold on a second. CPU is also updating that same buffer at frame 1. So there could be a possible resource conflict on the per frame resource between the CPU and GPU once we enter this double buffering pipeline strategy. So instead, what we want to do is, for the per frame resources, create duplicates for each frame. So if we have a double buffer, really, we need 2 separate copies of the per frame resources, just because we don't want any resource conflict while due to kind of the CPU uploading data to a buffer that is already being referenced by the GPU workload that's currently being executed on the GPU, right? So the reason I brought this up is because profiling or text rendering is, by its nature, they're going to get updated every frame from the app side. So we need some per frame storage for both the text for text buffer and the profile counters. That is why it's annoying, but I guess let's get to it. So let me just close this. Engine right now, all these resources, all these textures are the persistent resource type. They don't need to get duplicated per frame. So what I can say is, okay, so frame data or frame resource. Do I want to call this frame resource or frame data? You know what, I'm going to call this data because it's shorter. Alright, so we got frame data, some garbage. We can just put some stuff in it. The whole idea is if I put per frame data in this struct, I can just say, where should I put it? Frame data. Frame data, I can just say this, and I don't have to write the same variable names 2 times. Do I have a back buffer count? Okay, so this is what I want. Now, let's look at, so, alright, to completely sidestep the resource conflict issue, I'm just gonna have 2 separate GPU profilers for each back buffer resource. So it's been a while, so if I remember correctly, the way you do counters on the d3d12 is query heap or something like that. Oh cool, I can just search. So ID 3d12 query heap. Does it tell me the function I can use to create it? No, I guess not. Let me search through the d3d device. Create query heap. There it is. Okay. So for per frame, I want to store query heap. And let me just set up a routine for initializing the per frame data. I think I'll just put it here. Instead of init frame data, I'm just gonna initialize it in line there. So this will be just the boilerplate code for setting this up. Frame data. Frame data. So this will be specific to the current frame. Query heap. Now we just gotta fill out the heap disk. This will be for timestamp. And count, I don't know, guess like 100 or 1,000, because why not? Node mask, that's just gonna stay as 0. So now we got query heap calling from device, and if I remember correctly, the only thing, so now we can record counters with the query heap directly, and at the end, as long as we have a readback buffer, we can just map the counters to the readback buffer, and download the counters from GPU to CPU through the readback buffer. So query heap. Now I just want the API for recording timestamps, really. Begin query. Now I want to look at the type because there's something strange about the timestamp, I remember. So for all there are two API calls for query related stuff. One is begin query, one is end query. If I remember correctly, for the timestamp type query, the only valid API to call here is end query because all you're getting is a timestamp. I'm just trying to make sure that my memory is correct here. Please tell me it's right. Doesn't really say anything here. That's helpful. Dude, it's not telling me anything. So I'm just gonna assume that I'm right, which is probably gonna be the case. Now that just means current frame, back buffer. So what I'm gonna do is am I recording like a current? Okay, I do have a current back buffer index, so I'm gonna use that to basically say, okay, at each frame, I'm gonna get get a handle to the frame per frame data for the current back buffer. Now, the invariant here is at this point, all the executions that refers to the frame data will be done due to a stall that happens here. Basically, we're waiting for the GPU to finish executing on the next buffer index, and which this has already happened on the previous frame, so you will see that by the time we grab the reference to the frame data, that is ready to get pumped. You know, that frame is just ready to get pumped by the app side. So current back buffer index. That should be all we need, right? Why is it taking 3.5 seconds to compile? I don't understand. Okay. So end query, right? This is what we want. Okay, we need an index. This is great. So now oh boy. So I guess the preferred API will be begin profile attached to some so begin profile will give some identifier in the form of a string, primary pass, primary arrays. Then we have the command list that's gonna. Where do we want to put the command list first? So the reason I laughed was I forgot about the fact that we're explicitly tracking our own indices of the query, and therefore we need to create kind of an extra layer that tracks the current index, and just keep pushing those current indices for the next profile session. And I'm just sort of steering development of this with the writing the API first. So frame data begin profile and end profile. So this will command list and identifier. Now this identifier might be transient. What I mean by that is by the end of the call of begin profile, the string might no longer be in memory. So what I really want to do in begin profile is have my little, possibly my little memory arena that creates duplicates of these identifiers, so that by the end of my report of these profiles, the strings are still there. Just a minor issue I want to bring up. So begin profile, fine. So these functions are not going to be defined in profile. Okay. Does not take one argument. That's right. Alright. So let's see what I want to do here. Let's just spread the profile everywhere. It's going to be correlate history pixels and profile. Guess I could do this outside of the brackets, which makes it look real nice. Compute this occlusion. Path tracing. Pack gbuffer. Calc variance. This is tedious, but good thing is we only have to do this one time. Spatial filter. And last but not least, well, this is not even last. What the fuck am I saying? Not even gonna profile that one. Okay, these are sort of our counters. Now, obviously, we need sort of some kind of internal tracking logic for finding these, not finding, but just so we know which counter index corresponds to which portion of the profile session. So begin profile, now we're kind of fleshing out the body of the functions. Really hate d3d12 for their really long names. Just a hassle. Commit list. Now query index and query count. So I guess when we do that, I could have recorded what the count is, just to make sure we don't run over the amount of counters that's available to us. Let me just go back to where the frame data gets initialized. So frame query count is 1000 then. Begin profile. Cool. Now we just have to call end query, right? And amazingly, we actually have to do that. It's end query for both, because that's just how they decided to make this API work. So I'll have to assert that we're not, so query counter is going to be less than query index. Actually, that's less than it. Which way does the equality go? This is not quite, this doesn't look natural to me. I mean, this is what I wanted. I want to say there's more counters available. What the fuck am I asserting? No, I meant this. You know what? Fuck it. Let's not keep track of anything for now. So correct. Let's just say index is query index plus 1, and query heap. We already have that. If we query heap type timestamp, and index is just the index we have. Fetting. The hell is your problem? Did I say okay? Not heap type, I guess. And for this, it's just the exact same thing. And now we need to associate these two as a single session, which has this identifier attached to it. So we obviously need some more tracking to be done there. I'm looking at the chat right now. Wait, why did you delete his message? So data this, why Firefox instead of Chrome? Well, that's just personal preference. No, I'm using SDF for everything. You know, for some reason I didn't see these chat messages before because El Chapo deleted them. So can you stop deleting these messages, El Chapo? I don't really appreciate that. You know, these messages look good to me. They're not too offensive in particular. Okay. Okay, so let's see. Okay, we got a little sidetracked there. Okay, so now we can have something called, I guess we can have a little stack of profile session with our own name and begin index and end index. So a little profile session of, let's say, 1,000. Alright, so and we have a boolean say open. So is in session. Basically what I want to do is to avoid the scenario where I mistype, say you don't really know what the user is trying to do if they call begin profile twice. Okay, maybe they're trying to use it as a hierarchical profiler, but I'm not planning on making it one. So I'm trying to make sure that the opening and closing of each profile session is not You know what I'm talking about. So sir, this is not in session, is in session equals true. We're denoting that we're in the middle of a session now, and only end profiles should be called by that time. So during the interval of the session, there shall not be any begin profile being called, because that doesn't make sense. Okay, that's the bookkeeping part, and I guess now it's just session. We want a current session index. So now current session index equals, this is not even right. What was I even thinking when I typed these? Okay, session index is current session index plus plus. No, I'm not creating a new one. This is already a variable. Wait, it's just really hard to think when it's live. Okay, so basically current session, now think about it, it's just current session index. We're basically saying, okay, the way we're going to push in new sessions by the end, we're just going to increment this. Hopefully you can see why that works. So it should be quite obvious. Now, current session index. What we want to do is hook up our name with the identifier. So I guess I can use this function, string duplicate, and for this begin index, it can be this, of course. Current index and index is this index, and now we move on to the next session. So hopefully you can see how that works. So now let's just step through the code to make sure that this actually operates as we expect it to. It's a lot of compute calls. Okay, begin profile, frame, in session, no, and in session now, yes. So current index, let me just change this out of hexadecimal. Okay, index. So now the session's beginning timestamp is recorded at index 0. So yes, session 1, this is what you want. And here we see end profile, index. So the end index is 1. If we look at the sessions, this is exactly what we want. We've recorded one session with both indices recorded, right? In a name, which is good. What the hell? Oh, I forgot to update using session to false. So now this should work. Where was I? Okay, now this should work as expected. If you look at the sessions, you can see, okay, now we've got the primary array, session, correlate history, compute this occlusion, which doesn't have a end index yet. Okay, now it does. So now basically we have the query heap index associated with these query indices in a query heap. So now that is what we want. And what I want to do is, now I guess at the beginning of each, let me think about this. So now we go into the phase where we collect the counters, right? So do I want to do that at the end of the frame is the question here. So now with the GPU, now we know for sure that the next buffer index, the frame data for that has been finished. Yeah. So we can say collect or read back profile counters for the frame data of the next buffer index. So I can do that. Or maybe have it be a member function. Read back profile counters. Read back counters. Read back counters. Alright, so the function I guess is resolve query data. Now we just have to call this. This needs to be in the commandless resolve. I mean, this isn't too bad. We just need like a readback buffer inside that's local resource. That's going to be the counter buffer. And if I remember correctly, each counter is going to be 8-byte unsigned integer, so that'll make it easier to determine the size of our readback buffer. So if I have our init buffer function, frame, counter buffer, device byte count. Byte count is just U64 times query counter. Heap type, I want this to be a readback. And the initial state, I think, if it's a readback buffer, then it needs to be on resource state copy dist. And the flags is just, guess flags none. That should be it. Counter buffer. So let's step through to see if this buffer initialization is successful. Yes. Alright, so at the end of each frame, what I'm going to do is just say, this is near the end, so command list is going to query resolve query data. And let me just copy the function signature here. So frame, we got the frame, query heap, query type is timestamp, and start index is 0. Num query is just frame query index. Destination buffer is the counter buffer. Align destination offset is 0. So we do this. Yeah, that should be it. I don't think there should be any resource transitioning because that's not an ID3D resource that we're copying from. There should be in default a copy source state. So now we have it resolved from command list. And by the time we hit readback counters, that means the counter is already inside the counter buffer, right? Now, what we're going to do is, so we need to do two things. Readback counters, and we reset profiler. So now, the way you read it back, of course, is to do the resource map. Come on. Alrighty. So map basically just load the buffer data to the CPU. Read range possibly all. Which is 0 to size of u64 times whatever the current query index is, because that's equivalent to the number of counters we have. So that's the readback range, and the counter buffer will be just cast to void pointers, and that should be it. And it's going to be followed up by a unmap, counter buffer map, and then counter buffer unmap. If I remember correctly, the first argument is still the sub resource index. The second one is the range, which is going to be nothing because we don't write to it. So it's a readback buffer. So, oops, name collision. It's a problem. Right. Okay. This should give us all the counters we need. I'm thinking we're just gonna stick the so these are all the counters we have, right? So now we can basically say, so instead of having to print stuff on the screen, we can just say session I, current session index, session I. Why do I have 3s? What I can do is just give me that counter. Begin index is gonna be sessions. So I can do profile sessions, session I, begin index, or begin counter. I can just start to retrieve those counters. End index. And I believe, so one thing is that, okay, we can retrieve these counters, but the problem is to convert the counter to milliseconds, we need some, we need the clock frequency, but, I mean not the clock, but the wall tick frequency. And for some reason that's inside the command queue, so get timestamp frequency is what we want. And I don't know why we need to, call the command queue for that. But that's just something we gotta do. Timestamp frequency. Context. Command Q. Timestamp frequency. That should give us the frequency we need, and now to get the milliseconds, we just do this. Begin counter, convert to floating point, and then divided by timestamp frequency. That's gonna give us the seconds, and this will give us the milliseconds. And I'll just hit a debug break here. Now, before I reset profiler, I'll just make sure these counter collections are happening correctly. So read back counters. Okay. I guess if the current current index is 0, that means this frame hasn't been processed yet. So if current index is 0, then just return. Okay. 1.5 milliseconds, wonder what session this is. So, okay, 1.5 milliseconds for primary rays. And how many milliseconds? Let me just put that in the watch. For primary, okay, yes, I already know that. 0.1 for correlating, so that's almost nothing. Computer seclusion, nothing. Holy fuck. Path tracing is 145 milliseconds. Okay, that's a big killer. Pack G buffer, almost nothing again. Temporal filter, almost nothing. Calculate variance is 5.7 milliseconds. This is giving us a clue to what to optimize. So the first thing is definitely path tracing. Spatial filter is 8.7 milliseconds. That's a big one as well. I did not expect the variance calculation to be that high. Primary shading. That's just the second frame, isn't it? Okay, so yeah, so now we're just successfully reading from the counters, and I'll just reset profiler, add a to-do here, because I don't plan on doing any more of this. Probably put it off to next time. So now, let me just go over the counters we got again to kind of show where we're at. Alright, so primary rays. Primary rays. 1.5 millisecond. These small passes, I'm not even going to account for them, but path tracing is about 144 milliseconds. That's a huge one. And temporal filter, that's a sizable pass as well, but not nearly as big as the rest. Calc variance, for some reason that's so big. I need to look into that, of course. And spatial filter. So it's actually incredibly dominated by primary shading. It's actually incredibly dominated by the TA2. These are about expected, but path tracing, man, that is huge. That's a huge amount of processing time going to path tracing. So I guess now we know what to optimize. Well, I guess I just saved the note. Anyways, we're able to get these performances. So we got the performance counters, and next thing is wrap up per frame profiling. And holy cow, this is expensive. Path tracing, so well, let me just alright, so I think I'm gonna do the optimization next time, and now I'm gonna call it the day, I guess. The nice thing is of placing in these counters that I can't even run this again because it's gonna run out of counters without resetting the profiler. But I guess I can just temporarily removing these code here. It's just to recap, this is what sort of what we ended up with, which I'm pretty happy with. I think it looks real nice. Yep. So good. This looks so good. Alrighty. Yeah, I think I'm gonna call it a day. And